Hello. Previously, we have mentioned the elliptic curves on various transform, and today we are going to mention the Koblitz curves. This is different than the various transform, and its general equation is y squared plus xy is equal to x to the power of 3 plus a x squared plus b. As seen, they have different equations, and the graph of the Koblitz curves are like that. It's a little bit convolved as seen. And the main difference is this type curves are not symmetric about x-axis. For example, P and Q are they have same x coordinate, but they have different y coordinates. Let's find the relation its y coordinates. We have already known that this is the equation of the curves. Let's put the point of P's coordinates to the this curves equation, and it will become t squared plus mt is equal to m to the power of 3 plus am squared plus b. Similarly, let's put the coordinates of q to this equation, and this becomes n squared plus m times n is equal to m to the power of 3 plus am squared plus b. Right side are same for these two equations. Let's find the difference of these terms. I'm net p minus q. Right side will become 0 because they are same, but the left side will become t squared plus mt minus n squared minus mn, and it's equal to 0. Both n squared and mn terms have n multiplier. That's why I'll will express it as m common parenthesis t squared plus mt minus n times n plus m is equal to 0. This term are multiplication of minus n and plus n plus m. This means that I can express this equation as t minus n and t plus n plus m is equal to 0. In this case, it will either t minus n is equal to 0 or t plus n plus m is equal to 0. In the first case, t should be equal to n, and in the second case, t should be equal to minus n minus n. We have already known that actually n is on the curve. That's why I need to focus on the second term. I can express the coordinate of y coordinate of p as minus in the parentheses n plus n. Let's mention the addition law for this type curves. Just like in base transform, I will find two different points, and I will draw a linear line satisfying these points. This line would intersect a third point on the curve. For now, I don't know its coordinates, and I will find its negative point. And let's say its negative points coordinates x3 and y3. In previous slide, I have found the negative point calculation. In this case, minus r points y coordinate is equal to minus x3 minus y3. This is the equation of the curve, and I have already known that this blue linear line would satisfy this equation. Y is equal to beta times x plus mu. I will put this value beta times x plus mu instead of y in the main equation. and it will become beta times x plus mu squared value plus x times beta times x plus mu is equal to x to the power of 3 plus a times x squared plus b. I will reflect the power into the parentheses. First term squared value beta squared x squared. Second term squared value mu squared plus 2 times first term and second term, 2 times beta mu x plus, I will reflect this x into the parentheses, and this will become beta x squared plus mu x is equal to x to the power of 3 plus a x squared plus b. As seen, these orange lines show the x squared terms. Green lines states x multipliers, and the yellow line states constant values. I will combine x squared values here. A minus b squared minus b, a minus beta squared minus beta, sorry. Similarly, I will combine x multipliers. Minus 2 times beta times mu minus mu, and b minus mu squared values are constants here. Remember, in our previous lectures, we have proved the polynomial relation rule, and it says sum of the roots has to be equal to coefficient of the x squared. Actually, it's a negative value. I have already known that x1, x2, and x3 are three different distinct roots of the curve equation, and some of them have to be equal to minus x squared coefficient, which is a minus beta squared minus beta. I will reflect the minus sign into the parentheses, and right side will become minus a plus beta squared plus beta. And I wonder the value of x3 here, and that's the final form of x3. Now I'm going to calculate the y3 value. Sorry. X3 is calculated, and it's time to calculate the y3. Remember, blue linear line satisfies y is equal to beta times x plus mu equation. I will put here coordinates of p, which are x1 and y1, and equation would become like that. Y1 is equal to beta times x1 plus mu, and here I will find the exact mu value, and it becomes y1 minus beta times x1. Similarly, minus r on same line too. I will put its coordinates on this equation, and it's actually y coordinate minus x3 minus y3 is equal to beta times x3 plus mu. Here instead of mu I will put this value, and the equation would become like that: minus x3 minus y3 is equal to beta times x3 plus y1 minus beta times x1. Actually, this is almost equal to the previous term, and I will reflect the this minus sign into the right side, and x3 plus y3 is equal to minus beta times x3 minus y1 plus beta times x1. And I actually wonder the value of y3 because x3 is already calculated in the previous step. And y3's final value is equal to beta times x1. X1 is already known. Minus beta times x3. X3 is already known too. It's calculated in previous step. Minus y1, it's actually known to y coordinate of p because minus x3. Here, what's the value of beta? It's only unknown value for this case. Actually, for this case, I mean that p and q are different points. I need to find the slope, which is equal to y1 minus y2 over x1 minus x2 in the just like in the Weiss transform. But if doubling exists, I need to find the derivative again. For example, this point of P, I would find the tangent line, and this tangent line intersects the curve on a second point, and I will find its a negative point that would be 2p, and I will call its coordinate as x2 and y2. And remember the negative point calculation for Koblitz curves. Minus 2p's y coordinates should be equal to minus x2 minus y2. This is the equation of the Koblitz curve, and I will find its derivative 2 times the y plus this term includes both x and y, and that's why I need to find the x and the y here. Let's find the x value. It will become 1 times y times the x, and when finding the y value, x times the y. And the right side will become 3 times x squared, the x plus 2 times 8 times x plus 0. I need to find the dy value, dy over the x. In other words, derivative of y with respect to the x, and it will become this for doubling on Koblitz curves. And this is summary. Left side states the Weiss transform, and right side states the Koblitz curves equations. From now on, we have mentioned both Weiss transforms equations, formulas, and Koblitz curves calculations. Thank you for watching, and see you next time.